pre-quiz for section 7.5 through 7.7. So first of all, we're looking at just using no calculator and finding arc sine or sine inverse of root 3 over 2. So what we're looking for is the angle that gives us the answer to sine of some angle equals root 3 over 2. So really this says sine of some angle y is equal to root 3 over 2. And so that's what we're looking for. And this is a positive, so sine to sine is positive in the uppers up here. And root 3 over 2 might be somewhere up here, right? So we could use the left-hand method to figure out, or we could use the unit circle to figure out where it's at. And this is 60 degrees. So this is 60 degrees or pi thirds. So 60 degrees or pi thirds, but it's also true over here. I have the same height, right? And y in sine is the height, or the y value. So it's 60 degrees and would also be 120 degrees or pi thirds and 2 pi thirds. Okay, where sine negative 1/2. So we again look at the unit circle, we're at a negative, so that means we're below, right? So we find our reference angle by just looking at the positive 1/2. Well, if root 3 over 2 is 60 degrees, then 30 degrees would be, so 30 degrees, and you can do it like our answers, like interval notation. So 30 degrees would be our one of our answers, but that's just our reference angle. It's 30 degrees. So 30 degrees. So we would go down 30 here and down 30 here. So then our answer would be at 330 degrees, and also would be 210. So 210 degrees. So that would be our answers. And then or you can do radians, so that would be, we're at 30 degrees, so that's pi 6, so that's 11 pi 6 and 7 pi 6, so 7 pi 6, 11 pi 6, so that would be in radians. Okay, where do we get root 2? Well, root 2, I don't know off the top of my head, right? But I know it's bigger than square root 1, and square root 1 is equal to 1, so square root 2 must be bigger than 1, and sine cannot be bigger than 1, right? It goes up to 1 and goes down to negative 1. So this does not exist. There is no angle that's going to produce something bigger than 1. Okay. Where is cosine 0? So we can look at our unit circle, look at our x values. Where on the unit circle is our x value 0? Well, our x value 0 is right up here. Here, so that is at pi halves, at 3 pi halves, or at 90 degrees and 270. Okay, whereas cosecant root negative root 2, we'll worry about the negative in a little bit, but cosecant goes with sine, so I'm really looking at sine inverse, but I don't put a 1 over sine inverse, because the angles stay the same, what I'm looking for, but I flip, but then I flip this negative root 2, so it becomes negative 1 over root 2, which is root 2 over 2, so sine inverse of negative root 2 over 2. Well, root 2 over 2 would be a 45 degree angle, and we want negative, and negative's down below for sine. So this is going to be, our y value would be 315 and 225, or 7 pi fourths, 7 pi fourths, or 7 pi fourths and 5 pi fourths, sorry. Okay, and then tangent, where's tangent root 3? Well, I can get a root 3 by having a pi thirds and it's positive, so pi thirds, and then also in the third quadrant, tangent's also positive in the third quadrant, so that would be pi thirds and 4 pi thirds. So when I'm dividing by 3, that means tangent's going to be root 3. Okay, use the calculator to do this next part. Oh, I didn't do this cosine inverse of 1/2. So cosine inverse of 1/2, where's cosine 1/2 at? So that's going to be at 60 degrees, or pi thirds, but also cosine is positive on these two over here, so you get 1/2 for my x here, and 1/2 for my x here. So that's down 60, so that's at 300 degrees. Okay, so doing this on my calculator, kind of like I said, the couple ones above where we did cosecant, we don't flip the secant. Well, we do the reciprocal, which is cosine, so cosine inverse, but we flip this -1/4, so it's, or -4 to -1/4, right? Because cosine of theta, say it equals 3/4, that means that secant will equal 4/3. So here, see how I'm flipping my answer and not my angle? My angle stays the angle, but I flip my answer, so that's why I'm flipping this -4 to -1/4. Okay, so I don't know this answer, so I'm going to have to use my calculator. So this is what I'm going to type in my calculator. I'm going to type in, I'm going to do shift or second cosine, and then I'm going to hit the -1/4. And that's going to give me an answer in radians. Mine's in radians, okay, and that's what they asked for, so make sure your calculator's in radians. So that is 1.8235. We'll go up to 10,000th place. And so there's our answer for that one. Now going with cotangent, so the reciprocal is tangent. Tan inverse, and then I'm going to flip my answer here. So it's 1/-0.2528. So I'm going to put that in my calculator. And so here I get a negative answer of -1.323. And, oh, they want this in degrees, so I need to make sure my calculator is set right. So I need to switch to degree. And so I get -75.8129. And now, since this is negative, that means my answer is a negative answer, and tangent is negative in these two quadrants. So right now I'm at -75, so I'm somewhere down here. Well, if I go 180 degrees, I'll get the same answer, right? So I want to add 180 to this, and that's going to give me one of the answers. And at 104. So at 104. So there's my answer. And when you're doing the calculator one, just go ahead and just find the one answer for both of these. Will be fine. So the top one there was in radians, and this one was in degrees. Okay, so now we're not using a calculator here, and we're evaluating this. Remember, this is just some angle A, some angle B. So we're doing sine of the different angle here. So that'd be sine A cosine of B. Keep the sign the same. We're arranging the date for Sinbad, right? And his brother goes with her sister. Okay. So now I just need to find, okay, what is arctan of 4/3? That means tangent goes with, so this would be my y, this would be my x, the same, and then cosine is x over r. So we could use Pythagorean theorem on both of these. And 4 and 3, if I square those, I get 16 plus 9 equals r squared, so that's 25, so r equals 5. It's a 3, 4, 5 triangle. Same thing with this 12 and 13. I square those, I get 144 and 169, but I'm going to minus 169, and so I get 25, or 144 plus y squared equals 169. I subtract those, I get 25. so y is equal to 5. So now I can do the sine of A. Sine of A would be, well, it would be sine of arc tan of 4/3, but we're just doing sine of this first angle. So that would be y over r, so that's 4 over 5. Cosine of B would be x over r, so I already have that right, 12 over 13. And sine of B would be y, 5 over r, so 5 over 13. And cosine of A would be x, 3 over r, 5. Okay, so then we multiply these. We get 4 times 12 is 48. 5 times 13 is 65. Is 15, 65. Subtract those. We get 33 over 65. Okay, so we're just using the difference formula for sine, and then we're using our right triangles to figure out what our, either r is our missing side, right? Either our hypotenuse or our x or our y, and then we're finding the trig functions of each angle, the first angle and the second angle. Okay, here, same kind of thing. This is really just an angle, right? You can label it A, whatever you want to. Here we could do this as it's cotangent, and cotangent is x over y. So we don't have a denominator here, so if we put this under 1, this negative 5 over 1, that would be our y. We could use Pythagorean theorem here. So we have negative 5 squared is 25, 1 squared is 1. And that equals our r squared. So that's square root of 26 is our r. And now we're doing 2 times this angle. Okay, so 2 sine of 2 times a. Well, sine of 2a, 2 times our angle, is a formula, right? So we can actually expand this formula to 2 sine of a cosine of a. Okay, now sine of a would be y over r, so that's 1 over root 26. So if we rationalize that, we get root 26 over 26. And then cosine of a is x over r, so that's negative 5 over root 26. So that's negative 5 root 26 over 26. We're multiplying those, and then we're multiplying that by 2. And so we can simplify this. Let's see. Well, I actually probably don't want to do this yet, because I see that when we multiply this, right, on the bottoms, aren't I going to just get a negative 10 on top, and then on bottom I'll get a 26, right, because root 26 times root 26 is 26, and then we can just simplify that to negative 5 over 13. So that's probably an easier way than rationalizing the denominator first. Okay, so on these ones that we're solving, so we're solving here, so that means we can do things both sides, and our answers you can either put them in radians or degrees, but just from 0 to 2 pi is fine. Okay, so here we want to isolate the trig function tan of theta, so if we add root 3 to both sides, add root 3, we get 3 tan of theta equals root 3, divide by 3, divide by 3. Where is tan? Root 3 over 3. So root 3 over 3, and it's positive, right? So that means we're in the first and the fourth quadrant. So here we get our theta is equal to, and we have 2 3s, so that's a pi sixth. So that's just a pi sixth and a 7 pi sixth. Because 6 pi sixths is pi, and so I'm 1 pi sixth after that, so that's 7 pi sixths. So there's your answers for this first one. Okay, so here we're looking at, we have 2 different trig functions, so we might want to set one side equal to 0. So if we add cosine of theta to both sides, now I can't add to that because that is a cosine times cotangent, right? So this is going to be cosine of theta times cotangent of theta, and then plus cosine of theta equals 0. And so now I can go ahead and factor out a cosine because it's in both terms here. So I factor out the cosine of theta. I get left with the cotangent of theta, and then cosine over cosine is 1, so I need to put a 1 there, equals 0. And now since I'm multiplying here, 1 1 times 2, right? Two things. Then I can, and their answer is 0, that means that I can set them both equal to 0. It's called the zero product property. Two things multiply together and their answer is 0, that means that one of them or both of them have to be 0. So set them both equal to 0. Solve for the variable. So where is cotangent -1 and where is cosine 0? Well, cosine of 0, we already did this problem at the very beginning, right? Cosine of 0 was at 90 degrees and at 270 degrees. So 90 degrees and 270 degrees, that's our theta for this one, and then our theta for this one. Where's cotangent -1? Well, cotangent is negative in the fourth and the third quadrant, fourth and the second quadrant. So we want -1. Well, cosine is x over, cotangent is x over y. So that means where's our x and y the exact same? Well, that's when they're both root 2 over 2, right? So that would be at a 45-degree angle. But we're in the second quadrant, a 45-degree angle. In the second quadrant is 135, and then in the fourth quadrant is 315. So those are all answers for our theta here. And we can always, when we're solving, we can always plug these back in and check our work. Okay, so here we have something squared, so we're looking at probably a quadratic. So we can really say, okay, 3u squared minus u minus 2 equals 0. So we can go ahead and try to cab it first. If we can't cab it, then we can do quadratic formula. And so this is -6. 3 times -2 is -6, and our b is -1. So this would be a 3 and a 2 and a -2 at that, because 3 minus 2, oops, switch those around, so that's a negative and that's a plus. So that gets me -6 and that gets me -1. Alright, so then I have u minus 3 times u plus 2 equals 0, and then I have to divide these by my a, which is 3. So then I can set them equal to 0, so u equals +1, and u equals -2/3. Well, -2/3 I don't know, right? Now I can substitute my trig function back in, so this is sine of x equals 1, so where sine of x equal 1, that'd be at, sine is the y value, so that'd be at 90 degrees. And this one I don't know. Okay, so here we could do a right triangle. Actually, I don't want to do a right triangle here because I'm not, I can actually use my calculator here. So that's actually fine. It's kind of like the ones we did at the very beginning where it says use your calculator. So the same exact thing here. We want to take sine inverse of -2/3. Why I would use a right triangle if this was taking this and say like cosine, if it was something like that, then I would use the right triangle. But here I can just take, because I'm not finding another trig function after this, I'm just finding this one. So here I can use my calculator and just type in sine inverse. Sine inverse of -2/3. So I do that, and I get, if I'm in degrees, I get negative, so x equals -41.81. And so I can't use that one because it's negative. And so since sine, my answer is -2/3, my sine, when I give a negative answer for sine, I'm down here in the third and the fourth, so I'm at -41. So if I add 360, then I would land in the fourth quadrant right at the same spot. So if I add 360 to this, then I'll get my answer at 318. 318 degrees, 0.19. Okay, and then so that's one answer, but then I can also have an answer here, right? So I need to go back this distance. Well, what is this distance? Well, say if this distance is, say 315, and this would be a 225. What's the difference between those? Well, that's 90 degrees, right? And same thing, say if this was 300, this would be 240. What's the difference between those? Oh, not 240, sorry. So these are the right numbers, 240 and 300, because this is 60 here and this is 60 here. So you notice these also have the same answer. Well, these are actually not pi over 2 apart or 90 apart. These are actually only 60 apart, right? 30 to the middle and 30 to the middle. So, and then when we have, if they were just, say, 30, so that would be at 210 and at 330, well, 330, then this would be, then they'd be 90 apart, right? Am I right? No, not 90. 120, so they're actually 120 apart. That's because this is 60 and this is 60. And then the 45 one, that's like I said, 225 and 315. Those are 90 because this is 45 and this is 45. So they balance around that 270 mark, right? So if we can erase all this. So if we're at 318.19 is one of our answers, right, in degrees, then all I have to do is just figure out what this distance is from to 270 and then add it over here, and that will be my second number that has the same height as this one, right? So if we take 318 and we add 270, we get 48.19. So then if we take that away, so this distance from here to here is 48.19, and then we go ahead and take that away from 270, we get our second answer, which is this one over here, which is 221.81. So our second answer would be 221.81 degrees. So those are our answers that give us a sine of negative 2/3. Okay, here's another one. So this one set it equal to 0. So this one would be pretty easy to do because it's set equal to 0. But actually, it's not supposed to be set equal to 0. I knew something was wrong with this. It's actually supposed to be set equal to 1. Set it equal to 0 would be too easy for you. So set it equal to 1. We take cosine. Go ahead and distribute that to both of them. We get cosine squared x plus 2 cosine x equals 1. Subtract 1 from both sides. So then we have a quadratic. So now it's set equal to 0. Now we have a quadratic, so we can factor it. That'd be, let's say, u squared plus 2u minus 1 equals 0. We can't cab it because my CA is 1, but my B is 2, and I can't get a negative end here because that would just be -1 and -1. Or -1 and +1 would only get you to 0, right? So we can't cab it. So we have to do quadratic formula. So that's -b, so that's a -2, plus or minus the square root of -2, or 2 squared, which is 4, minus 4 times a, so 4 times 1 is 4, and then 4 times our c is -1, so that's a -4, but then we have a negative right here, so that makes a +4. And then all over 2a, so that's 2 on bottom. So we get -2 plus or minus the square root of 8 all over 2. We can factor out, or simplify that to 2 root 2 all over 2. Now we can cancel all those 2's because we have them in every term there. So we have -1 plus or minus the square root of 2. And then we can go ahead and substitute our u back in. So cosine of x is equal to -1 plus root 2. And cosine of x is equal to -1 minus root 2. Okay, so we have that. Now this one down here, square root 2 is about 1.4, so we're taking -1 and minus in 1.4. That's a minus like 2 point something. So that one's not going to exist, right? So we don't need to use this one because that one's over. That's a negative 2.4, so that's over 1, so that one does not exist, right? But so we can use this one, we can bring this one down, and so we do cosine inverse of -1 plus root 2 on our calculator, and we get approximately 1.143, so that is positive 37, and then we can add, so there's one of our answers, right? Now Now we have to think about cosine a little bit and the difference between them. So we want a positive number right here, because this answer is positive, like 1.4, right? So positive cosine would be in these two quadrants, here and here. So we got like a 1.4 here in radians, and we can also get a 1.4 here. So say if this was 30, this would be, you know, negative 30, so the distance is same apart, right? And then or it would be actually 3, let's do 330, a positive 330, okay? So then whatever the distance is, if this is 60, then this would be down 60 from 360, right? So we're going to take this answer, and then we're just going to take 2 pi, and we're going to subtract 1.1437, right? So we're going to take 2 pi and subtract that, and that's going to give us our second angle, which is, so x is equal to 1.1437, and then this one, x is approximately 5.1395. There you go. So those are our answers for x there on that one. So go ahead and switch that original one. Instead of a 0, make it be a 1 for number 15. So on this one, we definitely need to check our answer once we find it, make sure it works, because here I have two different trig functions, and I know cosecant and cotangent are related, but it's when they're squared, right? So we're going to square both sides here. We're going to square this as well, so we can FOIL this one out. This one's cotangent squared x minus 2 root 3 cotangent x, and then minus, or would it be plus 3 at the end there, and this is equal cosecant squared x. Now we can use our trig identities. We can switch cosecant squared x to 1 plus cotangent x, cotangent squared x, right? And then we can go ahead and move that cotangent squared x to both sides, or subtract it over. That means these are going to cancel, right? So those will cancel out. So that means we're going to get left with negative 2 root 3 times cotangent x plus 3 equals 1. Subtract 3, we get cotangent, or negative 2 root 3 cotangent x equals negative 2, divided by negative 2 root 3, negative 2 root 3. These negative 2's are going to cancel, so we get cotangent x equals 1 over root 3, which is the same as root 3 over 3. And really, we can actually might as well just leave that as 1 over root 3, because then we can write that as tangent, right? So we can take this over here, and so that is really tangent x equals plain root 3. Flip the fraction. Now we can do the inverse, right? So tan inverse of root 3 is equal to what? And so the angle to give me root 3 would be pi thirds. So pi thirds would give me that, but that's my reference angle, right? So here's my reference angle. So when I plug this thing back in, what I get when I plug it back in, I get a negative 1.15 on the left side, and the right side I get a positive 1.15. So that means I need to go ahead and do 180 degrees, or add a pi to this, and I would get 4 pi thirds. And then when I plug in 4 pi thirds into it, that's when it works out, right? So make sure you check your answer, especially when you square. When you square something, you need to come back and make sure that works out. So why it works out with the squareds is when I plug in just the pi thirds. So when I plug in pi thirds to here, that will give me a negative 1.15, and when I plug it in here, pi thirds into here, I'll get a positive 1.15. But when I square it, right, when I square this negative, I'll get the same answer squaring a positive. That's why I can't use pi thirds, because I squared both sides. And back to the original would delete these, right? Would delete these, and so that's why I need to put in a 4 pi thirds, because when I put in a 4 pi thirds, then it works out to negative negative. They're both negative, right? Because in the third quadrant, 4 pi thirds in the third quadrant, that will give me a negative here. The cotangent would be positive, but then you're subtracting a root 3, so that's why it turns to negative 1.15. And then cosecant in the third quadrant, it's part of sine, right? So that's going to be a negative. So it does work. Okay, number 17 here. So here we're doing the half angle, right? So we want to get this half angle by itself first. So we're going to add root 2 to both sides. So we get a 2 cosine of the half angle equals root 2. Divide that by 2, divide that by 2. So we get cosine of the half angle equals root 2 over 2. So that's a positive. So where's cosine root 2 over 2? Well, cosine is root 2 over 2 at 45 degrees, right? So at 45 degrees. And it's also at 315. Okay, so both of those, but now we're using our half angle, so we set our half angle equal to that, equal to these two. So that means we times it by 2, so x would be 90 degrees, and x would be 630 degrees. But since we're looking for just from 0 to 2 pi, we don't need this one because it's bigger. This one's bigger than 360, so we don't need that one. So we just need this one at 90 degrees. Okay, number 18, dealing with double angles here. So here we can use our double angle formula. And we want to use the one with sine in it because over to the right we have sine, so we want to use the double angle of cosine that has the sine formula in it. So 1 minus 2 sine squared of x equals sine of x. Then we can go ahead and move this over. So we have, I'm just going to put it so it's all positive here. We have 2 sine squared x plus sine x minus 1. Now we can use our quadratic formula here. Well, negative 2 is our CA, right? And our B is 1. So that would be a positive 2 and a negative 1. So this actually works out, right? We can cap it. So if we multiply those, we get negative 2, and if we take 2 minus 1, we get a 1. So this will cap. So we get sine of x plus 2, so that would be equal to negative 2, and then sine of x equals sine of x minus 1, so that means sine of x equals 1. Right? So this one we can't do because it's negative 2, so this one does not exist. So that's fine on that part. And then on this one, we want to go ahead and find out where sine is 1. Oops, I forgot to divide by my a, so make sure you divide by your a. Right, so our a is 2, so this is going to be divided by 2, and this will be divided by 2. So where is sine of x equal to negative 1? So that would be at 270 degrees, so 270 degrees. So 270 degrees. And where is sine 1/2? A positive, so that means we're in the first and second. And so that is at 30 degrees. And at the other side, so at 150. So at those three. Okay, so those are our answers for that one. So here it's a little complicated, right? We have some squareds and we have sine and cosine, so we have 2 of them. So one thing we can do is we can look for, is there any identities that this looks like? Like, is there a multiple angle where we're having cosine minus sine? So this kind of looks like the double angle of cosine, the first formula, but there should be a 1 here instead of 2. So if we divide everything by 2, that means we would get cosine, or just factor out at 2, I guess we could say, which is going to be eventually the same thing. But so if we factor out a 2, so put a 2 on the outside of this, we'd still have a plus 1 out here and equals 0. So really I'm just factoring out a 2, because then I can replace this with cosine of the double angle. Right. And that's being times by 2, and plus 1 equals 0. So then we can get this double angle by itself. So we subtract 1 on both sides. Get 2 times cosine of 2 theta equals -1 divided by 2. So now we have the double angle of cosine equal to -1/2. So where is cosine -1/2? So that'd be in the third and fourth, or sorry, third and the second quadrant. So 2 of theta equals, that'd be 60 as reference of 60 degrees. So that'd be at 120 and at 210. But we also have, since we're going 2 theta, so we're looking for answers between 0 and 360, right? 0 degrees and 360 degrees. But we have 2 theta, so if we times these both by 2, we get 2 theta should be between 0 and 720 degrees. So we're going to have to add 360 to both of these. So 360 is 480 and 570. Right, that's correct. Then we want to get theta by itself, so we're going to have to divide these. Oh, but not 210, sorry. Not 210, 240. 180 plus 60 is 240. So double that, that is, or times that by, or add, sorry, add that 360 to that real quick. So that's 300. 300 plus 300, 600. Okay, but then we need to divide, we need to get theta by itself, so we need to divide all these by 2. Divide by 2, divide by 2, divide by 2. And now we get our answers for theta alone. So that's 60 degrees, that's 120 degrees, that's 240 degrees, and 300 degrees. So those are all answers for that one. Okay, so here we're solving this for x, to get x by itself, and x is between pi 6 and negative pi 6. So we could graph this out and kind of see where our y's would be in between. But go ahead and just solve this for x, right? So we're going to divide by 4, divide by 4. So we get y over 4 is equal to tan of 3x. And then we can go ahead and do the inverse, right? Because that helps us find the angle. So basically these switch positions by doing the inverse. And that one's going to come over here. So tan inverse of our answer is going to equal our angle, and then we can divide this by 3 or multiply that by 1/3 on both sides. So 1/3 tan inverse of y over 4, and then we could graph this out and kind of see where our y should be in between, right? But this is our answer for x. Okay, so now we're going to have solve this, because now on this one we only have one variable, right, x, and that's what we're solving for. So first we need to get the arctan by itself, so we divide by 3 on both sides. So arctan, which is same as tan inverse of x, is equal to pi thirds. Now we can go ahead and go do the inverse. So arctan, the inverse of arctan is just regular tangent, and then our angle and our answer are going to switch places, right? So the tan of pi thirds is equal to x, and then I can go ahead and take tan of pi thirds, which is √3. So there's our answer for that. Okay, so now we're dealing with secant inverse secant of x, and equals cosecant inverse of 2. And so here we want to solve, right, for x. So I want to find that angle. Well, this is really just a number, right? It's just an angle, it's a number, right? So I can switch these by doing the inverse of secant, which is just regular, or inverse of secant inverse, which is secant. So they're going to switch places, and we've done these before a couple of lessons ago. And so here, inverse cosecant of 2 is taking sine inverse of 1/2, right? So this is asking what is the angle of sine that gives you 1/2, so that's 30 degrees, right? And now I'm taking secant of that. And what is secant of 30 degrees? Well, that would be cosine, which is √3 over 2, and then flipped, so which is, so this equal to x equal to x. And so that is, it'd be cosine, which is √3 over 2, and then flip it, so it's 2 over √3, and then rationalize that to 2 √3 over 3 is equal to x. So there's our answer for that. Okay, this last one, maybe you got one more after this. Solving this. So here we have two different trig functions. So we want to get it in terms of the other one, so it doesn't matter. I'm going to move the sign because it's a negative sign. So I'm going to move that. Arc sine of x. Okay, and now I can go ahead and do the inverse, right? This is the angle I'm trying to find, so then I can switch places with the whole answer. So these switch places. The inverse of arc cosine is cosine. So cosine of pi plus arc sine of x. And arc sine of x, isn't that just an angle? Equals x. So now I can use the sum formula for cosine, which is cosine goes with cosine. So I can write it all out here. Cosine of pi times cosine of arc cosine of sine of x. Cosine of arc sine of x. And then switch the signs, and then Sinbad goes with the brother. Okay. So sine of pi times sine of arc sine of x, which is just x, right? So this is just x, but sine of pi, that's 0. So 0 times x is just 0 there. So really all I need is the left side here. And cosine of pi is negative 1 times cosine of arc sine of x. And cosine of arc sine of x is, you can do this in a triangle. You put this over 1. All right, that's our x. That's our that 1 would be our r. So this is our r. This is our x. We can square those, and we can solve doing Pythagorean theorem. So basically, cosine is square root of 1 minus x squared. All right, and so then 1 times that would just be a negative. Let me just put this right here. So that is that one, and then times by this negative 1, so we just get negative root 1 minus x squared. And so that equals, because this equals x, this equals x, and this equals x. So now I got to get these x's by itself. So I need to square both sides, so it's going to get rid of those negatives. So then we just have 1 minus x squared equals x squared. You can add x squared to both sides. So we get 2x squared divided by 2 divided by 2. So x equals 1/2 x squared square root both sides. So we're going to get x is equal to the square root of 1, which is 1, and the square root of 2. So we get root 2 over 2. And then when we go in and we check this, we can see that it doesn't work out for root 2 over 2, but it does work out for negative root 2 over 2. And so that's it. Those are all our answers there.